All right, so I'll do my intro. I'm Deval, pronouns are he, him. My background is in AI algorithms and research at MIT, and then I spent a bunch of time building AI systems. For example, I built a big active learning pipeline on 50 billion tweets for the World Bank. I think the big reason we are having this panel here is that a lot of people are talking about ChatGPT, large language models, and they come to me because they think I know something about that. I kind of don't. I feel like that meme, like the dog that's in the room and everything is on fire. The dog is like, this is fine. This is how I feel because there's so much change happening. It's crazy. Everything is, changing pretty fast. And so I thought it would be a fun time for us to talk about what's going on and see how we can help as a philanthropic organization that funds science and AI and talent. So that's most of my intro. The last question that I'm going to ask everybody on the panel is, what's a nice dessert that you've had recently? And so I have to answer that question myself. And the nice dessert I've had recently is I went to this bakery. I just walked by Rosetta Bakery. It's like on the east side of Central Park. And they had this puff pastry that was full of custard and it was really good. And I ate 3 of them. It was great. All right, so why don't we start with intros? Do you want to start?
Oh, I want?
Yes.
Okay. Hi, everyone. I'm Qian Yang. I am an assistant professor in computer and information science from Cornell. Do I start with the proper intro or do I start with dessert intro?
Dessert.
You pick.
Okay.
You can go dessert first.
I'll go dessert first. A good dessert I had is maple syrup ice cream with olive oil.
Wow.
There's a restaurant called the Peter Croissant. Pardon my French. I don't actually speak French. In Montreal, anyone has gone there? It's great. It's in the middle of nowhere, but it's beautiful place. And they serve everything maple syrup, and that's one of their desserts. For work, I do hard turn. For work, I do research on human AI collaboration and thinking about how to sort of take the AI algorithmic advances as our sort of raw material and mold them to fit human needs in different contexts better. I work a lot in healthcare. I work with language models and human writing, human conversation contexts. Also.
Thank you. Yo.
So I'm Yonadav Shavid. This is nice to be back. I was at Schmidt Futures for a year ago. Right now I'm wrapping up my computer science PhD at Harvard, focused on AI policy, where my focus within that is primarily on sort of policy issues surrounding public safety and national security as they relate to AI. And I really target the verifying regulations and what it means on a technical level to actually enforce the various high-level asks that we have for and how to make sure that they're actually being complied with. And so the dessert that I have really enjoyed recently is that an indeterminate number of weeks ago, my wife cut up 2 bananas and dipped them in chocolate and then put them in the freezer. And I've been like taking little bites of this, and it is sort of healthy, but like very good. And I do it constantly. That's mine.
Hi, Dr. Elliott. So I'll start with dessert. I was in London all last week, and when the folks I was meeting with found out that I was vegan, they insisted on taking me to this amazing restaurant that was like, that's this 2-star Michelin restaurant that this French chef, the beginning of the pandemic, had an epiphany and converted his restaurant to completely vegan. Didn't lose his Michelin stars somehow. I don't know how that's even possible. And I ate like a 14-course vegan meal, including, I think, at least 3 courses of dessert that all, the problem is that all of them had a wine pairing to them. So I can't actually really remember what the dessert was, but it was
not a problem.
It was incredibly good. I mean, It was incredibly, incredibly good. I have no idea what it was because by that point I was so drunk. So, professionally, I am a program manager at DARPA in the Information Innovation Office. I've been there for over 5.5 years now, which officially makes me geriatric by DARPA standards. Usually we only stay for about 4, but I told them they were going to have to drag me out of there kicking and screaming, so they gave me another 2 years. I came to DARPA largely to create programs to apply technology, AI, et cetera, to improve science, to improve scientific modeling and expert workflows in general, to improve the way that science gets used for decision support, and also the way that scientists can create science better to be more transparent. Basically, scientists are terrible data engineers, they're terrible software engineers, they're terrible, X, Y, or Z, you name it. And our solutions that exist right now are to basically try to force scientists to be those things, and it's not scalable and it's terrible. So instead we need technology that can actually lower the barriers to doing those things so that the scientists don't have to do that. In the meantime, I became obsessed with education and especially adult education and the collapse of, collapse is a strong word. And how we could contribute to that. So I started some programs in that space, which is the first, way that I, initially got deeply involved with some of the wonderful people here, or maybe the wonderful people in Zoom land, I'm not really sure. And other various obsessions.
Hi, everyone. My name is Aditi, and I am an assistant professor at Carnegie Mellon. I just started a couple of months ago, last fall, and I did my PhD at Stanford before this. I work broadly in reliable machine learning, and in particular, most of these models work really well on benchmarks, but then when if we try really hard, or maybe not even that hard, we often find examples where they just don't work at all. And so how can we change the algorithms to make them more reliable when they learn patterns from data such that they can continue to work even when, we're outside this controlled benchmark setting. So, and as machine learning models have evolved, we studied the same questions, but in different settings. And so we've recently been thinking about how these questions manifest in large language models, I guess ChatGPT, which we'll talk more about. And in terms of dessert, I just recently moved to Pittsburgh, and I also realized about a month or 2 ago that I'm still a grad student at heart, because when we had these faculty candidates coming for dinner, and I realized they took you to really nice restaurants, I was like, oh, this is great. And so I got to sample a lot of good desserts, and the one that I had the last was really good. I think it was a pista cookie with cardamom ice cream and banana. I don't know, it was just really great. And I kept thinking I ordered it for the table, but I ate most of it. And I was like, I'm so glad I'm not the candidate interviewing, and I have my job. I was happy I was not interviewing, but yeah.
Awesome. Anna, do you want to do an intro?
Mute.
Okay, sorry, it was not permitting me to unmute myself. Hi, I'm Anna Makanju, and as the head of public policy of OpenAI, I've had to answer a lot of really challenging questions lately, but answering the question of what is my best dessert I've had recently is especially challenging. As someone who eats dessert at least 3 meals a day, usually more. But I'm here in the San Francisco office of OpenAI, which is actually rare for me because I'm not based here, and it's right next door to Tartine. So I've had all of their desserts in the last couple of days, and I can't say which one was the best. They were all excellent. But in any event, I lead all of the engagement with policy, or my team leads the engagement with policymakers here, which has been substantially more intense in the last couple of months. And also because OpenAI is this unusual place, which has this a mission that is the key driver of everything that we do, which is to ensure these tools benefit everyone. And we are governed by a nonprofit, which allows my work to be quite different than a public policy role would be at a typical company, and really think about what it means to operationalize and actualize our mission. So trying to think about how to, my sort of governing theory is that for these tools to benefit everyone, we really need to make sure that the earliest adopters of these are the organizations that are benefiting people, like governments, which are building for citizens, and of course, other organizations that are building for broad communities. And we're really trying to push in that direction as much as possible. I've been at OpenAI for about 1.5 years. I spent time at SpaceX and Meta before that doing public policy, and I was in the Obama administration for 8 years doing national security and foreign policy, including as a director for Russia on the National Security Council, and then working for Biden as his senior advisor on Europe, Russia, Turkey, Ukraine, basically that kind of slice of the world. And prior to that, I was an attorney working in also international law, particularly international criminal tribunals, ICC, and former tribunal for the former Yugoslavia.
Thank you. All right, the first question. So we're going to have like a few sections here. The first one is just understanding what all this stuff is about. Second would be a little bit about risks. And the third one would be opportunities for funding. So for the first one of understanding, what is ChatGPT and how does it work? I hear that it works using these things called neural network. So any of my panel members want to take a stab at like what the hell is a neural network? Okay, I'm gonna volunteer you.
All right. We're gonna go medium granularity, but not super granular. A reasonable way of thinking about how large language models work is that you take a very large amount of text and you attempt to get really, really, really good at predicting like the sequence of text that is about to come after the sequence of text that you show it right now. And this is a very simple operation. And it turns out that if you spend globs and globs and globs, tens of million or more of in compute, then you can actually get the level of prediction so good that it can essentially naturally evince many aspects of intelligence. Now, calling it intelligence is always controversial, but like, everything that you see online whenever you use ChatGPT is essentially the result of training a model to get good enough at, predicting the distribution of text that is about to come after what you're writing right now, with some additional fine tuning occurring at the sort of reinforcement learning stage, where you kind of push it towards some behaviors and away from others via techniques like RLHF.
Cool. We're gonna expand a lot on that, but I guess one question I have maybe for you, Joshua, is ChatGPT seems to be doing very well, but aren't there things that work really well before ChatGPT? Like, why is it so revolutionary? Like in your line of work, you've done a lot of linguistic analysis of documents.
Yeah.
What's so different about ChatGPT?
They put a really nice GUI on it.
Okay.
Yeah.
What's a GUI?
A graphical user interface.
Okay.
Yeah. No, they did a lot of great work on the human interface in general, both just the simplicity of the actual graphical interface to it, but also the conversational interface, and a lot of the work that goes on the more abstract layer from just the strict transformer model components in terms of question interpretation, et cetera. But I mean, I don't know. That's my impression.
One question for you is, so you spend a lot of time when we last talked in your research looking at how people write and like how different job professions write.
Right.
Can you talk a little bit about that? Why is ChatGPT and all these types of things going to be useful or not useful?
Interesting. I'll answer the second question first.
Okay.
I think here's my non-computer science understanding of ChatGPT. Prior to GPT, most often when we talk about AI, we say machine learning or AI models their capabilities are brittle. They're trained on one thing. You spend a lot of time to clean that data, build that model, and that model is good at that one narrow thing that the data set has taught the model to do. So it's good at one thing, and it's very brittle. Once you get out of that space, it's quite bad. It goes bad very fast. I think GPT really changes that. The way I think about GPT is, what do we do with this model, which is mediocre at everything? It offers a lot of possibilities for us. Like, like, for example, I work in healthcare, like previously it was just not realistic to build a model for each sub-disease specialty. It's just way too specialized to have that kind of data or resource to build those models. But with GPT, it's very easy to imagine a world where we can easily tune these models to serve each and every disease area. But also in our research, we find it's with GPT, it's easier than ever to get the first like roughly 80% right, to get to that 80% good. But it's harder than ever to get the last 20% or 10% good. It's very, very hard. We just submitted a paper called training, designing application with large language model is like herding cats. I love that paper title. But like the chasing that last bit is really hard. So then coming back to the first question, we spent a lot of, like I was working on writing assistants, how to build language models that help writers write better prior to the GPT craziness. And we spend a lot of time studying how writers write and think about at each moment, whatever document people are writing, what do people want? What kind of information is helpful? That's a very challenging question because if you ask, like recall the teachers that who taught you writing, like who was the best one? Those are the ones who did not tell you what to write. They're the ones that keep quiet, give you an interesting prompt, and encourage you. So when we think about how AI can help with that process, that's actually a very tricky question. And we studied like a wide range of writers from like Hollywood playwrights to New York's paper writers and people who are writing administrative documents and paperwork, do paperwork. And we really found there are just two kinds of writers. One is the kind of writer who writes for fun. If they're writing for the sake of thinking, they're writing for the sake of self-reflection. Those people, for those writing processes, AI it's just better to stay out of the way because it's all about thinking. It's not about the text you produce. And then there's a second type, which is people who have an audience to impress. They have some sort of a communicative goal trying to deliver to the audience. And in that case, well, like regardless of whether it's like trying to please your TV show audience or your paper readers, as long as there's an audience, I think there's a lot of roles AI can play by learning from the writing of that audience or the communication convention of that audience. And I think it's in that sense, like GPT or any kind of language models have a lot of potential as we move forward.
Thank you. Aditi, we talked a little bit about brittleness of models. So you do a lot of work on like guarantees and do you want to talk a little bit about your work relating to that?
Right. I think Chan did a great, way of saying that what we've seen is that models are getting really good at doing like majority of stuff well, like 80% of things well, but like that last bit of actually getting them to work 100% of the time has been challenging it's been kind of equally challenging over the past couple of years because now you're using them in more situations. So there's like more things you want to guarantee and that's getting harder and harder. And I think so when we started working on this, about 5-6 years ago, a very common problem in this space was adversarial examples where, there's an image of, I think, famously a panda, and then you add really small changes to every pixel, and it looks very much like the panda to all the human people, the eyes, but then the model would call it a completely different class. And so sort of why this was interesting was that it kind of made people realize that just because we trained something that was loosely inspired by the brain and showed it some data that looks realistic, it's not like the model actually learns to do image classification the way we would expect it to do, and it looks good on the test set, but it's not going to perform the way you would want it to perform. And that really started this whole list of things what about stop signs? How do we use them in self-driving cars if someone can meddle with it and so on. So, there were some ideas on how to defend, and we tried to come up with more guarantees. But two things that we realized was, one, it was really challenging, even for something as simple as saying that every pixel, I move it by some, epsilon. I tell you what that epsilon is, and you just have to guarantee to me that this model does that right. So it's a very, very well-defined problem. But even that, getting a model with guarantees, that also works well in practice is just incredibly hard. And that's a lot to do with just the structure of these neural networks. So they have, we didn't talk about what these models look like, partly because it's just really complicated. There are just a lot of parameters that all interact in complex ways, and it's hard to analytically say kind of just because it predicts something on this image, that now if I change everything in the input by a small amount, like how does that change the activations or like the function computation? That's very challenging. So over time, I think we've kind of realized that maybe it's harder to like actually give guarantees in the worst case, and we really need to change the problem to be a little bit more like what's reflective of the real world, like what are the situations that the model might actually encounter in practice, and try to guard against that, and so be a little less, worst case, and see if we can do something with that. But the problem with this is that now we don't have a well-defined notion of what we're trying to protect against. It really is that the more the model knows about the world, the sort of better it is. And it was sort of a good confluence with this whole, large-scale machine learning, because the way the model can be better at doing realistic things is to just show more data. And so models like GPT are really interesting because they have been trained on so much data that they do have some sense of like what are all the use cases that people are going to be trying to use the model for, and so on. So there's a lot of hope in like making these more reliable in the way that people actually use them. And I think one of the core things about ChatGPT was basically being able to get it to do dialogue-like things by just tuning on data that look like how people are going to interact with these systems. And so that's like a very direct way of improving performance. But at the same time, we're still doing this via like finite, like when we're doing this kind of fine tuning or like steering the model, we're still doing it on like much smaller scale data sets. And so we still have the problem that you might have made your model like work well for this particular way of questioning, but then I paraphrase the question and then like, all things are gone. So I feel like maybe we should change the question a little bit now, that like how do we modify what guarantees we want in this new regime where the model has seen a lot and it's probably good at a lot of free form, things out there, but the small changes to those, it still doesn't work. And so the kind of research questions have been shifted a little bit less around the worst case guarantees, but sort of like, maybe small changes to existing benchmarks, like do these models still do well, and how do we kind of bridge the gap from there to like the edge cases that we see.
Can I have a follow-up?
Yeah.
So I'm not as familiar with fields where the notion of safety and security is based around not worst case guarantees and not average case guarantees, but like kind of somewhere in between. Is there a way that you think about it, or like fields that you draw from, this sort of thing?
Yeah, that's a good question. I think this is one of those interesting, I guess it really depends on how we define where we're going to use these systems. And I think one thing that's missing from the general conversation around these models is like, what's the context in which we expect people to use these? So right now we're kind of just like letting it out in the wild and see what people try and things that we find wrong. So maybe a starting point is like a better definition of like, what is the context in which we want to actually use these systems? And I feel like maybe some of that is not really a computer science question, but more like people who use this or a policy and like building guardrails around that. And so when we talk about self-driving cars, I remember like, the common pushback was like, well, if someone could go and change the sticker on this, stop sign, then what's stopping them from like just removing the stop sign and causing an accident in that way, right? And so yes, it is true that if we now just like, so how do we define, basically, I feel like the question is like, how do we restrict the usage to the model in conversation with, the failures of the model so that we are balancing both. So maybe that's kind of the approach to take.
Anna, did you say you wanted to say something?
Oh, no, I just was still, I'm happy to take questions. I just was muted, so I wanted you to know I couldn't speak.
Well, I guess since we're talking about risks is basically what we're starting to get into the territory of here. I hear OpenAI is really working hard on these things called risk. Can you talk a little bit about what that means?
Well, I think that one key thing is that because these technologies are so new and so general, it is difficult for us just to use our imagination to determine what they all could be. So we do quite robust red teaming, for example. So when we trained GPT-4 many months before we released it, but we invited, we have, of course, internal experts who think and write about the sort of anticipated risks of these models. For example, one of the most detailed papers on this LLM-based disinformation was written by our researchers with CSET. But we also invited, for example, people who are experts in nuclear weapons, biological weapons, chemical weapons to work with the model to understand what capability does it have in this space, and how do you mitigate the model's ability to provide harmful information on that front. I mean, this is just a sliver. We obviously red teamed it on many different issues. And of course, it's also why we do both, initially limited releases with some trusted partners to understand, what other risks we may have missed. And another reason behind our approach, which is to deploy iteratively. I think that there are people who feel like you should, fully build a model, think of everything and think of all the safety mitigations and then deploy it when it is perfect. But we don't believe that's possible, which is why we deployed, GPT-2, 3, 4, and everything we learned from those deployments and the risks they have gets incorporated so that each model is safer than the previous model that was released.
I just want to add to that I mean, I think the big challenge, and it's obviously a massive gray area and uncertainty emerging right now, but is that the risk surface really expands as you start to give these models, not just conversational access, but access to the internet, access to APIs to do all sorts of different operations, access to be able to not just generate, but to actually execute code, access to be able to chain together multiple different models to do different things. And now we're talking about completely different emergent behaviors that can emerge from the combinations of these different agents and their interactions with all of these other functions. So we can, and I completely agree that, like, as an individual conversational agent within the confines and controls of say OpenAI or any number of other different conversational agent options, you can largely put in the kinds of controls that are required to reduce the risk so that it's not telling people how to make bombs or telling people how to do X, Y, or Z. But when these things start to get out into the wild and human creativity starts to take over and teach them how to use APIs so that they can access, any number of things and to write code and to execute code and to, that's where, to me, the big risks start to emerge. And I don't at all even know where to begin to seek what the answer to that is. But to me, that's where the big risks of it comes in.
I totally agree, and I would add maybe just two examples to think about that. One example is when we're talking to media or media regulation folks, one question that always comes up is, for example, people who are generating fake news can use ChatGPT to generate fake news. People who are regulating fake news can also use ChatGPT to create classifiers that tells lies from truth. But it's always easier to generate lies, and it's always more difficult to build systems that tell truth and lies apart. And it's in that sense, the same model can still in aggregate create systematic harms. And I think that's very much what Joshua was saying, it's the interaction that creates problem, not just the model. And the second example that I often think about is, let's say in the future, looking for a job, I write to ChatGPT and say, here are my top 3 qualities, write a really nice resume for me, or write a really good personal statement for me. And I send it email to a recruiter, and the recruiter used ChatGPT to summarize that personal statement into 3 bullet points that I originally wrote to ChatGPT anyway. So assuming me, the job applicant, and the recruiter have the exact same model, have the exact same capabilities, basically the effect cancels out. But then the question is, of course, there are people who are more technically fluent, who have $20 to pay the premium plan for ChatGPT, or have larger amount of resources to fine tune the model and to outperform the other side. So in that sense, when we talk about the societal impact of ChatGPT, are we just talking about will there be an arms race in that case? The thing is, I totally agree with Joshua saying, I think it's those interactive effects, how the society will, and the organizations' existing human inequalities, how those factors will compound with ChatGPT, I think that's really concerning to me personally.
So two words I hear that I want to expand on, whoever wants to take either of them, is this emergent thing keeps coming up. Like, what does that mean? And then the other word is this arms race stuff keeps coming up. So it's on for auction. Who wants to take which one?
Sorry, what's the first one?
Emergence.
Emergent.
Oh, emergence.
Well, I wouldn't mind talking about my arms race, but maybe from a very, very different perspective, which is, let's be very clear. The cat is out of the bag, and we should. If you've ever tried to shove a cat into a bag, you know that it's not a thing that you want to try and do, right? So, me?
Yeah.
Oh yeah. To get them to the vet, I have 3 cats, so it's like trying to get them into their little carrier thing to get them to the vet. Nightmare. So, I think the key needs to be thinking about, and especially, what I would like to probably convey to this audience here is like thinking about how we can start to, given this very uncertain environment and rapidly evolving technology, how can we start to create scenarios of what a future of public good and positivity and reduced risk looks like? And how can philanthropy start to create the sort of the seed funding, the risk funding that can help to chart the course for hopefully governments to be able to follow suit, right? And I mean, I think a key example of that for me is in education, and I'll be even more specific, is in like reskilling and upskilling of our existing workforces, right? As these AI technologies and technologies in general continue to accelerate and continue to quote unquote threaten or displace jobs, which we can argue all day long about to what extent that's actually true or not. The fact of the matter is that millions and tens of millions, perhaps even more, just in the United States alone, are going to have to require new and improved and increased skills, and are going to have to require those things to be continuously improved. So like we need to think about now, how can we use these technologies? How can we leverage these technologies to accomplish that, to accomplish the goals of continuous learning and upskilling and reskilling, so that the human beings that need to be able to use these tools don't, become obsolete, and we don't have the same kind of, unfortunate, lagged inertia challenges that we've had in other technological revolutions over the last 140 years.
You were gonna say something?
I was also going to talk about arms races, and I mean, I agree with what you're saying. I do want to suggest that the cat is not totally out of the bag. Like, it's like halfway through.
There are more cats coming.
Right, there are a lot of cats in this bag.
Starting the schedule.
Yeah, and not to get into the whole discourse about like the Future of Life Institute letter, and like literally pausing everything, but like we are very much within the realm that like government regulation and even industry standard setting can like still dramatically affect the trajectory of like exactly what gets developed. Like it's certainly true that like the cat is out of the bag as far as like 12 billion parameter models trained on like most of the internet. Like those are open source. There's no way you are ever going to stop people from using them. But that's not the case for anything of the size of and effectiveness of GPT-3. It's not really the case or it's certainly not the case for anything like GPT-4. It's certainly not the case for whatever the big labs produce a year or two from now. And like we're still in the realm where even if you were to open source like a bunch of these models that are created in the cutting edge right now, like we're probably not talking about societal collapse. It's like there are a bunch of problems, but like it's within the realm of.
Sorry,
I think this is a really important point, though, because I think you're 100% right, but that there is urgency in ensuring that we create some sort of floor for safety of these models and to mitigate their potential risks. And there are efforts along these lines. I think now everyone is moving quite quickly to identify something, but it is quite urgent to create industry norms which exist around almost nothing in this space, and some regulatory guardrails. And so, yeah, just would say violent agreement, because Sam always likes to say, like, the thing everyone needs to understand about these models is that they are the weakest and most ineffective they will ever be right now.
I agree with everything that's been said. I just want to add one more point. Like when we talk about risk or safety, there is risk and safety in terms of artifact. There is risk and safety in terms of process. Like one question sometimes I entertain myself with is, like FDA has a set of processes. Like if you want to ever deploy a new medicine that's gonna hit the market, here is a procedure you follow. You run this series of experiments. By the end of it, you have proven this thing is effective and you can go, this new medicine can go on the market. We don't have anything like that in tech and model training. We're kind of, I think when I talk to policy folks, of course, not the ones here,
The other ones.
of course, the ones who are not working with OpenAI, a lot of them feel like they're working very reactively to the emergence of these new models. And I think that's good to hear that there are more cats coming. So for those future cats, is there a way for us to think about how to engage the public in a more ongoing basis earlier before the big model is released, before there is a PDF that, shows the evaluation?
I just want to make sure that, I mean, for my perspective and the reason I say the cat's out of the bag, I guess, is because I'm coming at it from, the national security perspective that I've been embedded in for the last several years, right? And, the narrative that seems to be very, very prevalent there is one of unilateral disarmament, right? I mean, we can regulate and slow down model development all we want, but there are plenty of, bad actors out there who do not have those motivations. And there's plenty of, at this point, already sufficiently powerful open source tools to be able to substantially accelerate, the efficiency of cyber warfare, substantially accelerate the efficiency of information warfare. And so, I just don't see a way for us to, through a mechanism of slowing down our own development, when we're clearly can't slow down global development of these technologies. I think it has to be a more of a defensive and counter posture than that's where I say the cat's completely out of the bag, I suppose, from a different perspective. Yes.
I want to jump in about emergence since no one spoke about that. And I think it's relevant to like the context of like, the cats in the bag. Okay, so I guess we spoke a little bit about like, these language models, and you explained how what they're trained to do is they take text and they predict what's coming next. And I think what was not that surprising was that models are good at minimizing this objective function you gave them, which is to predict the next word given everything that you saw. What was really surprising is what emerged as a result of optimizing this objective, right? So until then, everyone knew how to train networks and they knew they could get that loss down. But what was not clear was what would happen. And one thing that was very interesting was that now the model, by just seeing text on the internet and doing this sort of simple objective, like just predicting the next text, like no one had annotated in any careful way, but was able to do very complex tasks that like showed some signs of reasoning, could like combine facts together in some interesting way, could solve arithmetic, could like learn what you're saying from what you're giving in text. So I think that was sort of like a example of an emergence where it was not something we trained the model to do, but we just trained on something that looked slightly different from the object. Like we just trained it on data, like to predict the next word, but now the model seemed intelligent. And so now I guess the question is like, now that we've realized that by just training on a lot of data that exists, we can get models to do interesting things. So I feel like that is sort of like not going to, like we're never going to be able to tell people to not train on more data and do more things. But now the question is like, what other properties might emerge? And I think we don't have a good way to talk about this. And an example of this is, I don't know how many people followed this like Sparks of AGI paper that came from Microsoft. And there was a, okay, so sorry. So one problem with the not knowing what the model was trained on is like, how surprising is it that model gets capabilities of like, just because there's like a lot of stuff that's on the internet and the model has been trained on. And so there was this task of generating a unicorn in like LaTeX code, which was like supposedly improving as GPT-4 was being trained. And there was the implicit assumption that like, okay, the model has to have like got this by emergence, because why should there be some unicorn on the internet in like LaTeX? And then a couple of days later, people dug up some repositories of someone who like, had animals and unicorns in LaTeX. And so like now, because I think this is kind of the problem is like how much of this is predictable in terms of just things that are already there, the model is just sort of picking up on, versus like truly new things that are out of our creativity, like that, do not exist on the internet, the model is going to discover. And I feel like the policy question kind of has to lag behind the emergence because we cannot predict what's going to happen. But so I don't know how to deal with that aspect.
All right, so time has gone much faster than I expected. We only have 10 minutes left, so I want to open it up to Q&A. Dan, do you want to be the Q&A?
Sure.
Like.
Well, the mic is over here, so I'll be the mic runner.
Okay. All right, so I guess one question, I will start the Q&A for the panelists. If somehow there was an organization out there that had a lot of money and was interested in funding AI research and policy, what would you ask? What do you think is like the next thing that we should be funding that nobody else is doing? Any idea?
Well, I'll try to be short. AI plus X, right? Whether X is synthetic biology or protein design or, computational modeling or, I don't know, philosophy. I mean, like, who knows? Like, the potential for it to transform things and trying to get ahead of that as much as possible so that we can at least get the wonderful benefits of this AI before it destroys us all. Sorry, that was a joke.
You shouldn't make those jokes.
No, I know. So the AI plus X, I think, is still a ripe area. Obviously, there's already been huge improvements in so many different fields, and AlphaFold and all sorts of wonderful scientific applications. But I think there's still now, especially with conversational agents, et cetera, there's a whole new subclass of those that are opening up. And then I'll just repeat what I said earlier about trying to identify what do we believe are the socially good paths forward, and how do we try to ensure that we can get on those paths. I don't know how philanthropy funds that, but somebody needs to be thinking about that. And so far, I don't see a lot of people doing it.
I think I know some place that's thinking about that.
Oh.
Yeah.
Maybe to jump on that a little bit, on Aditi's final point about emergence and how difficult it is to deal with this from a regulatory perspective. I mean, I actually just think that funding research on very high quality evaluation of the capabilities of cutting edge models is hugely valuable. It's not a very exciting thing because you're not the person who is unleashing it into the world or whatever, but all of policy is blocked on us not having a reliable way to take a model that is in front of us and say, yes, this is fine or this is not fine. And in fact, all the technical development, it's like machine learning people are exceptional at, if you give them any sort of metric, creating some magic box that optimizes that metric. But we don't really have a robust societal method for really reliably figuring out what language models can and can't do, including what will happen when you expose them to all sorts of varying conditions. And so, Anna talked about, how OpenAI brought in a few different folks with different specializations with respect to weapons of mass destruction, right? I am very interested in the question of what does it look like when you get the actual Department of Energy or various folks within the government to do this the adult way, where you are staking some meaningful notion of national security on your certainty that this came out right. And right now, we don't have anybody who does that seriously. We have some people who are thinking about how to attempt it. But in my opinion, you could probably blow a couple $2 billion on just trying to get everybody to do the best that they could at this and see what emerges in terms of best practices.
Any other questions?
If I had billions of dollars, I wouldn't fund that.
Okay, great.
Because here's how I think about again, like GPT is a foundation model. You can fine tune it, you can tweak it. You prompt it, it's already changing. So it's in that sense, I think evaluation metrics is not particularly useful, but it's more like, how do we regulate this 3D printing technology that can print guns? Rather than saying how we're going to regulate guns, because ChatGPT is the 3D printer that's going to print out all the different kinds of things. Can be useful, can be very hurtful. How do you regulate that? I have no idea. I'm going to leave it to you guys. My short answer to your question about like what kind of work to fund, I would again add on to what Josh was saying. I think it's not like AI plus X, but it's AI across X. I think the traditional way of thinking about, AI for healthcare, AI for like science, like it's like ChatGPT does everything. It's like, how is it different from asking ChatGPT a medical question versus asking a politics question? I think I would really love to see some sort of support for like radically cross-disciplinary research, because I think those disciplinary boundaries are no longer relevant in the context of GPT.
Questions from audience or? Don't be shy, yeah?
I got handed the microphone, so without asking, but I do have a question. So I think if we had this panel a year ago, right, we'd probably still be talking about large language models. But if we had it 2 years ago, we would be talking about reinforcement learning and AlphaFold. Before that, we would have been talking about GANs and adversarial examples. And before that, we were talking about convolutional neural networks. So AI has been changing really, really fast. And so I have no confidence that that large language models are an endpoint, right? So I wonder, if we were going to have this panel next year, what would we be talking about? And I thought maybe I'd ask the panelists.
Hard question.
Language is simply an interface between lots of different, more complex AI models that may be based on probabilistic programming or other simulation interfaces that can actually generate real world models and run them to generate real things. And then coupling those things into robots to actually do things in the real world. And then you probably need like literally quantum computers to do all that computer. Otherwise the robot's going to move really slowly. But I don't know. Yeah, I really think that language and language models, I think I'm really intrigued by the idea that they're not an end in themselves. What they are is an interface between different elements of human cognition, or not human, between different elements of cognition, machine or human, right? They're the translation layer. They're the incredibly efficient information transition layer that we've come up with. And we've now like kind of cracked that in machine intelligence. Like it can do language. How do we couple that in? Well, we've already coupled it into now like coding, right? So it can generate code. Now can it build modeling? Can it start to do the other kind of cognitive elements, or some version of the other cognitive elements of human cognition? And can language be that communication layer between them? I'm just literally talking out of my something.
Cat, bag.
Yeah.
I will just to be contrarian, I'll say that I think I don't think language is special, because if one thing that was common in all the trends that you listed was like data and scale, right? Like we kept getting better at compute and data, and I think people are just going to find different ways of getting more data from some way, and like training and finding a technology that can use them. So transformers are not special. It's just that they're capable of fitting like all the data that exists. And so I think we're going to start finding new and creative ways of like harnessing large scale data sets. And I don't know if I can predict what's the domain that's going to change next, but I would predict that it's going to be some creative use of large scale data. And then we'll continue to have the same security and robustness questions, but there'll be a different domain.
Okay, so we have 3 minutes left. We're going to take one last question.
Okay, one quick question. What do you think? Do you think the energy and carbon costs of running these models is in any way a limiter, or no? The energy and carbon cost of running large language model, is it a limiter or is it not?
So
Ask our OpenAI.
not OpenAI, but no. If you look at the inference costs for individual queries, so they're more expensive than most computing tasks, right? And it is true that one of the main limiters to expanding the scale of ML operations is getting permits to site data centers near cheap electricity locations. And to have like grid level interconnects to facilitate all of that, but we're not like close to a cap. Like I believe that if you so like the thing that's limiting our energy consumption is the quantity of chips coming off the line at cutting edge TSMC fabs. Which are, so most of AI is run on NVIDIA GPUs, and NVIDIA, if you were to 10x the annual quantity of GPUs that they are producing, and then you were to run them at the maximal rate that they are approved to run, just like 300 watts or something like that, you math it all out, like I think I did this calculation, I think it's about 1% of global energy use. So like, that's not gonna be the thing that stops us.
And that's before.
That's training and inference put together. That's training and inference put together.
That's run your GPU at maximum speed, whether it's training or inference.
I guess we are out of time. I guess I just want to say thank you to our panelists for coming. It was really great to have you. I want to say a special shout out to the AI 2050 team, two of our panelists are AI 2050 fellows. Thank